Okay, moving into the next section, 8.4. We're going to spend 2 days here. Before we get to the new stuff, I want to quickly review the very first time we did integrals in Chapter 5. And remember, an integral is finding the area under a curve. So say we had this parabola, and it would give you, find the interval from some a value to some b value. F of x. The area under this curve, remember, was found by dividing it up into little rectangles, and the integral, which went from the lower boundary to the upper boundary of the function dx. And remember what this was doing, the function, the f of x value, was giving you the height of the rectangle, that's the f of x, and the dx was the width of the rectangle. So this is actually finding the area of a single rectangle, and by doing it from a to b, it covers the whole interval. What we're going to do in this section is find the area between two curves, which is going to end up being a very similar process to this. So let's take a generic two functions. Say I've got, let's go with another parabola. And then I'll go with, let's see, I'll call that f of x. And I'll go with, say, a linear function, g of x. And I create a bounded region, bounded because it's enclosed by the two functions. What we're going to do today is be able to find the area enclosed by these two functions by, again, finding the areas of the rectangles. As long as the rectangle touches, the top touches one function, the bottom touches another, we're good to go. And it doesn't matter where I draw my rectangle, you can see it's always going to touch the parabola on top and the linear function on the bottom, all the way through here. Okay, let me go through the process, and as I explain the steps, I'll kind of point back to the picture here. So the first step, obviously, is to sketch the two functions. And draw in the rectangle. Okay. After that, you need to determine which function is on top, this will help us set up our integral, because we want the height of the function to be a positive. So we have to go do top minus bottom when that comes up. That's in the next step. But so you have to know which function's on top and which one's on the bottom. So then the third step is to find the domain of the bounded region. Find the domain of the bounded region. So in other words, you want to know what part of the x-axis does the first intersection start at to the other end of the intersection. So this would be our domain from the two intersection points. And you're going to find that by setting the two equations equal to each other, because they are equal at this point, and then we'll use those two x values. So you set the equations equal and solve for x. Occasionally you're going to come up with something that you can't solve by hand, and in that case you can use your intersect on the calculator. So you'd have both of them graph, remember, and you've got that second calc, the intersect, and it'll help you find the intersections. We aren't doing one today, I don't think, but maybe on your homework. But most of the time, if it can be done algebraically, I want you to do it algebraically to practice that algebra. Okay, so you find your domains, you find your a and b. Now your fourth step is to actually write the integral. So set up the integral. And the way you do that is you'll already have your boundaries here from step 3. So you'll have your boundaries from A to B. And then what you want in here is the height of the rectangle. The height of the rectangle. And we'll look back and I'll show you how to do that. And then the width of the rectangle. Your width is dx. So that's how wide it is, dx wide. Now the height, I want this distance from this y value to this y value. Well, that's just this top function, because the top function takes you from here all the way to the top, minus this bottom function, because the bottom function takes you up to here. And if we subtract those two distances, it's going to leave me with this part in the middle. So it's the top function, which is our parabola, minus the bottom function. So that will give me my height, top minus bottom. If you get those reversed, it's just going to give you a negative area like we talked about back in chapter 5. So, and then we just solve it. Do the integration like we've been working on for months now. Okay, these are not too challenging. There's a lot of algebra and stuff going on, but as far as difficulty, they're not too bad. So let's practice a couple. Okay, find the area bounded by. F of x equals x squared minus 4x plus 3, and g of x, which equals negative 2x plus 3. Okay, so first thing we need is a sketch. You have to graph them. I know one's a parabola, one is a line. We got x squared minus 4x plus 3, negative 2x plus 3. Do a zoom 6. There's my parabola, and there's my line. I can see there's a little region in here. If we want to see more of it, I'll just get rid of some of this x-axis. I'll go negative 3 to 5. Should be able to pick up more of it there. Okay, so it's just a very small region. So I've got a parabola that's doing this. And then a linear function that's coming through here. Okay, so there's my region. My rectangle, I can see, is going to touch the linear function on top and the parabola on the bottom, all the way through here. So now, so that was step 1 and step 2. Now I can find the domain. So let's get the domain. I need these intersection points. I need this and this, and I want to solve it algebraically if I can. So these 2 points are where the two functions are equal to each other, so you set that up. X squared minus 4x plus 3 equals negative 2x plus 3. Okay. I can see this is a quadratic equation here. I can get it equal to 0, so I'm going to add 2x to both sides and subtract 3. X squared minus 2x, that's gone, equals 0. At this point, you could grab your quadratic formula program, or you can realize, boy, I can factor this. X minus 2. Okay, hopefully I would rather have you do it this way, but if you get stuck and have to use quadratic formula, that's okay too. Now you set each factor equal to 0. So now I know that this point actually was on the y-axis. So I'll make the point a little bigger so it hits it. So my intersection there is at 0, and then this one over here is over at 2. Okay, now I'm ready to set up the integral. So it is the integral from 0 to 2. Now I've got to do the height of my rectangle. And I actually think I'd like to do it off to the side. To get the height of the rectangle, it's going to be the top function minus the bottom function. So the top function is this linear function, negative 2x plus 3. I've got to subtract the parabola, and I'm going to need parentheses because there's 3 parts to the parabola. X squared minus 4x plus 3. Now if I just simplify in here, I'll have a nice expression for my height. I guess I'd rather do all this algebra off to the side and then set up my integral. So I'll have negative 2x plus 3, distributing a negative, negative x squared plus 4x minus 3, combining like terms, bringing the negative x squared to the front. I'll have a plus 2x when I combine there, and the 3's cancel out. So yeah, I would do the height off to the side, just keeps it a little bit cleaner. So negative x squared plus 2x, all times dx. So there's my height times my width. And now we just do antiderivative, do the integral. Okay, so I do each term by itself, add 1 to the exponent, multiply by the reciprocal. Moving on here, add 1 to the exponent, carry along the 2, so it's 2 times x squared, times by the reciprocal of that is a half. And I'll evaluate from 0 to 2. I think I'll simplify that first. The 2's will cancel, I'll have x squared. And now plugging in the 2, let's see, I will get 2 cubed is 8, negative 8 thirds, plus 2 squared is 4, and then minus, that'll be 0 plus 0, don't have to worry about that. I guess I better do that just to keep my form going. First one 0, second one 0, subtract them after I add them together. Okay, this will be 12 thirds here when I multiply by 3 over 3. So negative 8 plus 12 is 4 thirds. Or 1 1/3, or pick up a calculator. Okay, not so bad. A lot of work, but nothing too challenging, I don't think. Just got to be careful with your algebra. Okay, number 2. We want the area bounded by f of x equals sine x and g of x equals cosine x. Okay, and I am actually going to give you the boundaries from x equals pi over 4 to 5 pi over 4. Okay, so a sketch would still be nice. Here's doing one of the steps for you by giving you this intersection, but I'll show you what you could do if that didn't happen. So we've got y equals cosine x and sine x. Doesn't matter which goes in first. Do a zoom trig.